Alright, so we're on, guys. Alright. Okay, so we want to kind of solve this integral here. So the biggest thing we got to realize is looks kind of like the Pythagorean theorem. Regardless of what you think about that, still does have that same sort of situation to it. So we want to set up a triangle. I hope this marker turns out okay. And the big thing to realize is you need to know where that side belongs. It could be on one of the legs or it could be on the hypotenuse. And anytime you're adding them together, you're usually adding them together to get the hypotenuse. So this is our hypotenuse, the 1 plus the x squared. And then the two missing sides, if you think backwards in the Pythagorean theorem, are going to be, well, 1 and x. And you can always check it through the Pythagorean theorem. Now, whichever order you put them in is really kind of up to you. But we just have to choose one. So now we got to come up with two kind of relationships here. We need one that's going to be in terms of x, and we need one that's going to be in terms of this square root. So if we let this be our angle, we want to avoid the sine function because the sine is going to have x and the square root involved in it. So we can use the cosine or the tangent. So, well, let's try one. So if we use the tangent of theta, that's going to give us our opposite over adjacent. So x basically over 1, right? Alright, so that's a good place to find dx. The other relationship that we want to kind of highlight is the cosine of theta. So if we use the cosine of theta, that's going to be 1 over the square root of 1 plus x squared. So if we rewrote this, the square root of 1 plus x squared is going to be 1 over the cosine of theta, which we could write as the secant of theta if we'd like to. However, when we substitute it back in there, it's going to end up flipping back up to the top. So let's try substituting everything back. So when we do this integral, we put this, the 1 plus x squared, is 1 over cosine. So we can put it in the bottom, 1 over cosine of theta, but most people would probably flip that directly up to the top of the function. Now, you still need a dx. So we know that x equals the tangent of theta. I don't know, our voice is okay on YouTube? I think so. So what's dx going to be? Anybody?
Secant squared of theta.
I don't want to be wrong, huh? Alright, no problem. So we got dx is going to be in here. Let's put it here. So dx equals secant squared theta, d theta. Alright, so that's our dx. So let's put it up here. So secant squared theta, d theta. So we really have put this all into terms of thetas and in all the stuff that we've been used to dealing with the trig functions. So let's clean this up a little bit. So 1 over cosine of x is really just going to be, well, cosine of theta over, well, you end up with cosine of theta again, right? On the bottom. Cosine squared theta, sorry. Alright, so here's the problem. They're going to cancel out and you're going to have a cosine on the bottom. Well, don't forget our d theta. It's not really a problem. So we have secant of theta d theta. Secant of theta d theta. Now that's not one that we remember all that well, right guys? But it is one of the ones that we should know. Now I don't want to get this wrong, so I'm going to double check in front of my book and just double check it out. So we got secant of theta, so that ends up being one of the natural log ones, which is a fun one. So that's the natural log of secant of u plus tangent of u. So ln of secant of theta plus tangent of theta plus c. Now, this is where we got stuck at the end of the class period on Friday. We got here, but we didn't go back into x's, right? How do we go to x's? What's that? Arctan. Maybe.
Use a triangle.
Use a triangle. So secant of theta, if I've got this triangle, it's got theta in terms of all my sides, right? Secant of theta is going to be corresponding to the cosine of theta, right?
Yeah.
So we have cosine of theta. I mean, we can write it down if we want to. So cosine of theta is, oh, I think I just erased it, didn't I? Oh, well. Here's tangent of theta is x, right? Cosine of theta is 1 over the square root of 1 plus x squared. I did just erase that, didn't I?
Yes.
Well, that's wonderful. Okay, no big deal. So to find the secant, you're just going to take the reciprocal. That's how that happens. Alright, so we really have the natural log of, instead of secant, instead of cosine, we're using secant, which is going to be the square root of 1 plus x squared. And then plus the tangent of theta, which we know is x. Plus c. And we got it. Alright, thanks.